Welcome to homework.
19.11, we have a 12-volt battery with a couple of 4-watt light bulbs attached to it. We'll discuss what that means in a moment. And we find that the voltage across the terminals of the battery is 11.8 volts with these light bulbs connected. And so what the 4 watts means is that if you apply an actual full 12 volts to it, the light bulb will dissipate 4 watts of power. So from this, we can infer what their resistances are, and then given that, the rest is much like all the other internal resistance of a battery problems we've already seen. So a convenient expression for the power in a resistor is often V squared over R. This comes from the definition of power as I times V and Ohm's law. And so you get I is V over R, and then you get this. I squared R is also the other one specific to a resistor, and sometimes that's helpful. But in this case, we know the voltage, the nominal voltage, which is 12 volts, because again, this is what it's rated for, what the power rating comes from, and not what's specific to this particular situation. It's sort of an important distinction to keep in mind. So we have 12 volts squared divided by 4 watts, or no, 4 ohms. Oh, well, no. We want to rearrange this for the resistance first, sorry. R equals V squared over P. And now this is our 12 volts squared divided by 4 watts. This is better. And so this is 36 ohms. So that's the resistance of one light bulb. The resistance of the 2 light bulbs in parallel is just half the resistance of one of them because they're identical. And if you have n identical resistors in parallel, then the equivalent resistance is 1 over n times the resistance of one of them. So the equivalent resistance is 18 ohms. And so the terminal resistance is the voltage across this equivalent resistance. And so we can use that to find the current that's being drawn from the battery. So V, the terminal voltage, is equal to the current flowing through our equivalent resistor here times that equivalent resistance. And you can rearrange that. I equals V over R. So it's 2 times this voltage divided by the R of one of them. Now V is also equal to the EMF minus that current times the internal resistance. And so rearranging this and simplifying and putting in our expression for I over here, we get that the internal resistance is the resistance of one of the resistors times the difference between the EMF of the battery and its terminal voltage divided by 2 times that terminal voltage. And this is 0.3 ohms.